Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight I'll do the review for test number 2. But before I do that, I'd like to remind you, don't forget, hand in your labs. They're easy points if you do them. They're not that hard, but you got to hand them in. So most of you have, but I'm just reminding you, keep on handing your labs in. You all should have got an email from me with the grading for labs. I think it was 2, 3, and 4. I like my special effects 4. All right, let me just remind you about test number 2 before I do the review. And test number 2, I'll be giving it this Thursday online, and I'll send out an email with the password for the password protected PDF file that will be in the assignment area. Test 2 has 9 pages, excuse me, and 10 problems. Some of the problems are multiple part. In Chem 170, I never have, never will give multiple choice. This test covers the functional groups alcohols, thiols, ethers, reactions of ethylene oxide, aldehydes, and ketones, which are modules 5 through 9, not chapters, the modules. All right, test number 2 point breakdown or points breakdown. General knowledge, 11. Nomenclature, 34. Reaction, 60. Now, nomenclature, there are 2 types of nomenclature problem. One is, here's the structure, give the IUPAC name. The other is, here's the name, either common or IUPAC, draw the structure. For reactions, most, except for 3 or 4 questions, are give the reaction product or products. Those 3 or 4 questions out of the 60 points will be give the starting materials, which is another way of saying synthesis problem. In other words, how do you make this? And it adds up to 105. So there's 5 bonus points. And again, this is not open notes, open internet, or have help from a friend. Do it on your own. Take as much time as you need, as long as you get it uploaded by Friday, the 11th of this month, October, by 8 p.m. All right. Let's start review 2, or for test number 2. What you see on your screen is in the lecture section of wrong school, in the in the lecture section of D2L, cleverly named test number 2 review. All right, let's start. Alcohol, that's a hydroxyl group OH on a carbon in a molecule. How do you name it? Find the longest chain that has the hydroxyl group, name it as an alkane. Next, drop the E, add OL, and if it's acyclic in a chain, you need a number. Which carbon is the hydroxyl group on? And that always has highest priority, meaning the lowest number. If it's cyclic in a ring, no number, because in this class, that carbon will always be 1. Now, this molecule, benzene ring on with a hydroxyl group, IUPAC in their infinite wisdom decided to say, well, chemists have been calling this phenol for eons. We're not going to change them. So the name of this is phenol, and that is the IUPAC name. Now, I taught you the common names, and the common names are, for an alcohol, the structure ROH. Remember, R can be anything with carbon and hydrogens. Name the R as the alkyl group it is, and then add the word alcohol. at the end. An example of that would be this molecule right here. Now, the IUPAC name would be ethanol. This is the only acyclic that you don't need a number because you can't have two ethanol. You can only have one ethanol. But the common name, which a lot of times you'll see on bottles of wine, that's my R group, that's ethyl, and then alcohol. Now, since in common knowledge, you should know some real world uses of these molecules that's going to be on test number 2, let's talk about rubbing alcohol. And rubbing alcohol is a product that you can buy at many stores like Walmart, or as my friend calls it, his favorite French store, Target. But anyways, it's anywhere from 70 to 90% isopropyl alcohol and the remainder 30 to 10% water, depending on which type of rubbing alcohol you get. And it's a good product to have in the house. I keep some, and it's also a good disinfectant. All right, let's talk about how do you make an alcohol. And this is a reaction. It's the only one that of the 4 tests will be on more than one test. Like test 1, it was test 2. If you have a double bond reacted with H plus, that's acid catalyst, and water, think of water as HOH. You break the pi bond, one carbon of the double bond gets H, the other gets the hydroxyl group, and it follows Markovnikov's rule. The carbon with the most hydrogens on the double bond carbon gets the hydrogen in the product. The other carbon of double bond gets the OH group. Now, before I go any further, there's something I had better do. And now a public service announcement from the management me. For test 2, remember, there's 4 bonds to carbon. I gotta get that finger fixed. 4 bonds to carbon. Yes, 4. So when you're drawing a structure, make sure your carbons that you change only have 4 bonds, not 3, not 5. One time a student, I still had 6 bonds to carbon. Nope, that's wrong. It's always going to be wrong. But 4 bonds to carbon. The other thing you should remember for test 2 from this public service announcement, do you break carbon-carbon single bonds? No. I'll do it again in slow motion. Do you break carbon-carbon single bonds? No, don't. It's going to be wrong. All right, let's go to next now, reactions of alcohols. The next one is quite challenging for a number of students. That's the reaction of alcohol with sulfuric acid and heat, sometimes called dehydration of alcohol. Dehydration, you're losing water, H and OH. And you get a double bond, and it follows Zasev's rule, which is why I abbreviate Z, because I'll probably spell his name wrong. Dr. White was always the first one down to spelling bee. Math and science, no, I won those. Spelling, yeah. Anyways, Zasev's rule is you get the double bond that has the most carbon atoms directly bonded to the carbon of the double bond. All right, let's take a look at Zasev's rule. And this little triangle means heat. Sometimes I also might write a temperature like this. That also means high heat. And the question is, what is the product or products you get, organic products in this reaction? Now, if we look at this, we look for what's different. That's another thing. When you're looking at a reaction or even a name, a compound, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like this. That's my favorite toy, one of them. By the way, never grow up, always have fun with your toys. All right, so here, what's different is an alcohol. And adjacent carbon, if we have a hydrogen, adjacent being attached to carbon with the hydroxyl group. You get a double bond, use the hydrogen hydroxyl group, and it follows Zaysev's rule. Now, if we look at this molecule, there's the hydroxyl group. But we have, let's call this A, that's one adjacent carbon with hydrogens, and this would be B. So if we have the hydroxyl group leaving and a hydrogen from A, notice I didn't break any carbon-carbon single bonds. Here's the carbon with the hydroxyl group. Here's the carbon with the hydrogen. So between that, there would be a double bond now. Remember, there's 4 bonds to carbon, so I can put in my hydrogens. And that would be the product if you lost a hydrogen from A. Carbon, which has the 3 hydrogens. Now, for B, if we lost the hydroxyl group and this hydrogen, notice I didn't break any carbon-carbon single bonds. Now, the hydroxyl group, carbon is this one, and the carbon you lose the hydrogen from is this one, so the double bond will be there. And now I'll put in my hydrogens. Now, Zaysev's rule says the product you get is the product that has the most carbon atoms directly bonded to the carbons of the double bond. In this case, in A, there's only 1. In B, carbons directly bond to the carbons of the double bond. 1, 2. So now you have to use your high-level math skill. Remember, on this test, you're not allowed to use a calculator. But anyways, this has 1, this has 2, which is the greater number. And time's up. Hopefully you picked 1. Therefore, this is not your answer. B would be your answer. And that's how you do Zaysev's rule, dehydration of an alcohol. All right, let's look at some other reactions. Here, the next one is I take any alcohol, react it with an acid, it'll form HX, where X can be chlorine, bromine, or iodine. You replace the hydroxyl group on the carbon that had the hydroxyl group with the halogen. And remember, you don't break carbon-carbon single bonds. Next, if you have an alcohol and you react with SOCl2 called thionyl chloride, and Dr. White's done these reactions in the lab, you get the hydroxyl group replaced with a chlorine, and this is a way of making an alkyl chloride, which are useful compounds. Now, moving on. Alcohols, you can have primary or secondary alcohols or tertiary. I will not ask on my test or the final what's a primary, what's a secondary or tertiary alcohol. But if you take a primary alcohol and bracket O, closed bracket, means oxidizing reagent, and there are many. I'm not asking to learn it. Just learn the general symbol, which is a bracket with an O, closed bracket. You lose these two hydrogens and form a carbon-oxygen double bond. The rest of the R group comes along for the ride because you don't break carbon-carbon single bonds. And you make, and we'll learn later on in this review, an aldehyde. If you take a secondary alcohol, where R and R prime can be the same or different, remember R is anything with carbon and hydrogens in it, and you oxidize it, that's what bracket O, close bracket, means. You lose these two hydrogens and form a carbon-oxygen double bond, and now you make a ketone. If you watch the videos, you know Dr. White loves aldehydes and ketones, and they love me too. My first patent dealt with aldehydes. My last patent dealt with ketones. And a lot of the work I did in between was with aldehydes and ketones. All right. Next, I talked about thiols. Thiols are the sulfur equivalent of an alcohol. Instead of ROH, you have RSH, or S is sulfur. And the two things you should know about thiols are, one, they stink. And I mean stink. The defensive weapon of a skunk is mainly two thiols plus some water. If you've ever been around where a skunk lets loose, it stinks. Now, to use the property of thiols being stinky, I mean really stinky, I told the horrific story about that tragedy in Texas in the 1930s with natural gas, because natural gas, methane, is odorless. And because of that tragedy, since then, in the United States, and I'm pretty sure it's worldwide, but I'm not positive, but in the United States, natural gas, they add a thiol so you can smell it if there's a leak. And that's T-butyl thiol, or also the old name, T-butyl mercaptan. And they only put 3 pounds of that, are you ready for this? Per billion pounds of natural gas. And that's enough to let you, ooh, there's a leak. All right, next, ethers. And ethers, I didn't ask you to learn nomenclature of thiols. Ethers are the form ROH. ROR, I'm sorry. An example of an ether. In this case, R and R prime are the same. And I only asked you to know the common name because nobody really uses IUPAC names for ethers. And the one I just draw, the common name, you name each group as an alkyl group and add the word ether. And notice I have one ethyl group, two. So what I just drew here is diethyl ether, which is probably one of the most common used ethers in a chemical lab. Now, how do you make an ether? Well, that's the Williamson ether synthesis, named after Dr. Williamson, who invented this. And if you take RO minus Na plus, that's called an alkoxide, and an alkyl halide, R prime with a halogen, where X halogen can be chlorine, bromine, or iodine, you take, and this, did I tell you organic chemists are very violent? This attacks this carbon, kicks this off, you get this salt, and this oxygen bonds to the carbon in R prime that the halogen was bonded to, and you form an ether. And the question is, give the organic product or products for the following. And how do you do that? Well, first of all, let's finish this. And we look and say, what's different? Ooh, oxygen minus charge, sodium cation, and an alkyl group. That's an alkoxide. Carbon-carbon iodine on a carbon, more carbons. That's an alkyl halide, R prime X, where this is my R group. This is my R prime. And what do you get? This attacks that, and it forms an ether. Now, you don't have to, but I'm going to put down, you get a salt to NaX. And remember, X can be chlorine, bromine, or iodine. And the carbon with the halogen is the carbon that this oxygen will be bonded to. Well, if we look at R prime, there's 4 carbons. Which carbon had the halogen? This one. And that's the one this oxygen will be bonded to. What's R? 2 carbons. And I know there are 4 bonds to carbon. And this is one way of drawing this. And that's how you do it. Next, something at first glance looks like an ether, but it's not, because chemistry is much different, are epoxides. And I only asked you to learn one epoxide. That's the simplest one, ethylene oxide, a ring with 2 carbons and oxygen. And this is the common name, not the IUPAC. Nobody ever uses the IUPAC name. And Dr. White worked with this at 2 companies. It's interesting stuff. And it's used to make a lot of products you use in your daily life. But anyways, 2 reactions I asked you to learn with ethylene oxide is if you take an alcohol and react it with 1 molecule or mole of ethylene oxide, you get this ether alcohol. Now, if you take an alcohol and react it with N moles or molecules of an ether alcohol, of an epoxide, you get this polyether alcohol. This OCH2CH2 bracket N, that's repeated N times. The important thing is the hydroxyl group is on the outside of the bracket, not inside. And if I were asked, give the organic product or products for the following reaction, what do? Well, you look for what's different. what's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like this. I got to do it another time. And this got my attention. That's an alcohol. And this got my attention along with this. This is N moles or molecules of ethylene oxide. And the general reaction would be this. Remember, the hydroxyl group goes outside of the bracket. If it's inside, it's wrong because that can't exist. What's my R group? A methyl. What's my N? 18. So R is methyl. Bracket OCH2, CH2, close bracket, N is 18, and then my hydroxyl group. And that's how you make a poly, meaning many, ether alcohol. And now, notice big smile, we get into something Dr. White really likes. This is one of my favorite functional group areas, and that's aldehydes and ketones. An aldehyde is a carbon double bond to an oxygen, with the carbon that's double bond to oxygen having a hydrogen and an R group. That's called an aldehyde. A ketone, carbon double bond to oxygen with two R groups. They can be the same or different, and that's called a ketone. Now, if you have an aldehyde, you find the longest chain with the carbon double bond to oxygen and name it as an alkane. Drop the E, add Al. No numbers needed because the carbon double bond to oxygen in aldehyde is always number one. I like these special effects. I can do it with this hand too, always number one. You can't have an aldehyde in a ring, so we don't have to worry about cyclic aldehydes. All right, now a ketone, you can have acyclic or cyclic. Acyclic meaning straight chain, cyclic meaning in a ring. Dr. White and Mother Nature loves cyclic ketones. And both cases, you find the longest chain or the ring with the carbon double bond to oxygen. Name it as an alkane or cycloalkane. Drop the E and add ONE. For acyclic, you need to number, just like in alcohols, the carbon double bond to oxygen. That always has the lowest number. In a cyclic ketone, you don't need a number because the carbon double bond to oxygen is always one. Now, there are two common names I asked you to learn. And the simplest aldehyde, when R is H, is called formaldehyde. And Dr. White, my last patent, dealt with use of formaldehyde and other things. And I worked for a company at one time, a long time ago, Borden Chemical, now Hexion, which is the largest manufacturer of formaldehyde in the country, if not the world. I don't know about now, but back then it was the world. And nobody calls that methanal, which would be the IUPAC name. And I talked about the dangers of formaldehyde if it's not used properly. Next, the simplest ketone with both R and R prime, our methyl groups, is called acetone. Nobody calls it 2-propanone, the IUPAC name, except when to tell you nobody calls it that, like I just did. It's acetone. And just to remind you, acetone is the main product you can buy at a store for nail polish remover. I'll teach you another one later in another chapter. But most, if you go to a big box store, you'll find they have acetone take off your nail polish. Ooh, don't look, I forgot to polish my nails. No, I don't polish my nails. But back my grandfather's day when I was a little kid and I'd go with him to the barber shop. If I was spending time with him, he'd have to go to the barber shop. Men used to have a clear coat put on their nails at the high-end barber shops, and he did. Now, something very important, so important, I have it in red. If you look at a ketone or aldehyde, both have a carbon double bond to oxygen. And that has a special name. That's called a carbonyl group. And you should know, what is a carbonyl group? Hint, hold on, Dr. White has to be subtle. Time to be subtle. See how subtle I can be? Hint, know this. Carbonyl group. You should know how to describe with a diagram, how to draw, and how to describe with words what is a carbonyl group. And here I have carbon double bond to oxygen with some other things on it. And it's described as a carbon atom double bonded to an oxygen atom. And as I mentioned in my video, if somebody were to ask me what kind of organic chemist am I, and if I really answered honestly, I would have to say I'm a carbonyl synthetic organic chemist, because most of my work I did with carbonyl groups. Carbonyl groups are not functional groups, but they make up a number of different functional groups like ketones and aldehydes. Now, how do you make a ketone or aldehyde? Well, we already talked about it in alcohols. If you take a primary alcohol and oxidize it, you'll get an aldehyde. Yay! And I did some of these reactions for my PhD thesis, which dealt heavily with aldehydes and ketones, my favorite. See, it helped me get a PhD. Take a primary alcohol, lose hydrogen here and here. Remember, O, bracket, O, close bracket, means oxidizing reagent. And you'll see in one of the labs when we get into ketone aldehydes lab, potassium dichromate or sodium dichromate is one, and potassium permanganate is another. And there are other oxidizing agents. But I'm not going to ask you to learn all those. Thank you, Dr. White. You're welcome. But anyways, you should know bracket O, close bracket, oxidizing agent. If you oxidize a primary alcohol, you get an aldehyde. If you oxidize a secondary alcohol, you get a ketone. Now, a really special reaction is Friedel-Crafts acylation. That's where you take a benzene ring and react it with this is called an acid chloride, R group carbonyl chloride, and aluminum trichloride, and you'll make an aromatic ketone, where one of the R groups is a benzene ring. And I told you some of these molecules are used in what's called photochemistry, which is very important. And some of these, when this R group has an aromatic ring in it, also are used in suntan lotion to absorb UV light from damaging your skin and giving you cancer. All right, let's talk about some important reactions. These are for both aldehyde and ketone. When R prime is carbons, that's a ketone. When R prime is hydrogen, that's an aldehyde. So if you take an aldehyde or ketone, react with an alcohol, ROH, acid catalyst, H+, you form, and I'm not asking you to learn the name, a hemiacetal or hemiketal. Keep your eye on the carbonyl carbon. That's where all the fun is. And what's attached to it, R prime or H and R double prime, are still there. you break the pi bond in the carbonyl group, carbon double bond to oxygen, and the oxygen gets a hydrogen from the ORH, the alcohol, and the OR bonds this way to that carbon. Now, if you have two alcohols, and oops, something fell off the page. Don't look. If you take an aldehyde or ketone and react it now with two molecules of alcohol and an acid catalyst, you lose this, and the carbonyl carbon was attached to it, R prime H, our double prime is still attached to it, and you get OR, two of them on that carbon. This is acetal and ketal. Now, these two reactions, I'll teach you later on, Mother Nature, who's by far the greatest of all organic chemists, used to make starches. If it wasn't for these two reactions, you wouldn't have any starches, carbohydrates in your life. You know, the good things like pasta, pizza, French fries, rice. None of that would exist if there weren't these two reactions. Now, I taught you a special case that my PhD advisor, Dr. Roosh, I'll be forever grateful, because he trained me to be a synthetic organic chemist, and other members in our research group too. His advisor that he got his PhD, Stork, Dr. Stork, came up with this special reaction. You take an aldehyde and ketone and use ethylene glycol. That's CH2OH, CH2OH. And that's the same as having two alcohols in the same molecule. You form this acetal or ketal. Now, for some reason, students forget to put this bond between the CH2 and CH2. Don't know why. And I don't go into it in this, but this is a way of protecting a ketone or aldehyde when you're doing other reactions and a reagent might react with that ketone or aldehyde, and you don't want to. Sort of like putting on a raincoat in a rainstorm or opening an umbrella, and then you can put it away or take it off, which you can do this when you're done. Now, these two reactions right here in the special case, and the next two reactions, I will never do a synthesis problem on. Again, these two reactions and the next two I'll teach you, I will never do a synthesis. That's cruel and unusual punishment. And I think the Supreme Court still outlaws it, but who knows with the Supreme Court. Anyways, I won't do it. Now, once you get a hemiacetal, where R prime can be hydrogen or carbons, or hemiketal, and react it with acid, H plus, and water, you break it back down to the alcohol and the ketone or aldehyde you would have used to make that. And if you have an acetal or ketal, when there are two OR groups on the carbon, same carbon, acid and water, you'll come back and break it back down to the aldehyde and ketone you would have used, and the alcohol you would have used to make that. Let me say that again. You get back the aldehyde or ketone plus the alcohol. Now, as I told the story years ago at another school, I also taught the same course. It's called 1212 XCOD. I had these two twin sisters who were very nice, other than if I didn't balance things, which organic chemists are lazy and don't, they got upset. I mean, they got ballistic. Two twins, stereo, ballistic. So that's why you'll see sometimes a little two here. You don't have to put it there. Don't go ballistic on me, please. Now, these two reactions, look, this is the only two examples I know in all of organic chemistry where you have two oxygens bonded to the same carbon, single bonded. two oxygen single bonds, same carbon. They both give back the aldehyde or ketone plus the alcohol you would have used to make that molecule. So that's a hint. By the way, we'll come back to these two reactions because these two reactions are the reactions your stomach uses. Remember, in your stomach, you have H plus, hydrochloric acid, and acid, and you definitely have water. Speaking about which, I'm going to take a drink first. Definitely have water. And this is how your stomach breaks down carbohydrates like starch. So if you had those potato chips or pizza or rice or potatoes, this is what's going on in your stomach. Now we're going to get some fun stuff. Oh, I love the next two reactions. If you have an alkyl halide reacted with magnesium, where X would be chlorine, bromine, or iodine, you form the Grignard reagent, named after the great French organic chemist, Dr. Victor Grignard. And he's my hero in organic chemistry, one of them. And remember, the carbon with the halogen has the magnesium, and the magnesium is bonded to the halogen, not the other way around. And this is the way you do it. Now, why am I getting all excited about this? Because the other thing, by the way, for these two reactions and some other work, but mainly these two, Victor Grignard won the Nobel Prize, and I'm guessing I may be off by a couple of years, right around 1910, over 100 years ago. Wow. And that's if you take a ketone or aldehyde, first step reacted with a Grignard, second step acid and water. You do something very special, very rare. You make a carbon-carbon single bond. The carbon with the MgX bonds to what was the carbonyl carbon, and you form an alcohol. Remember, X would be chlorine, bromine, or iodine. And let's have some fun with it. I have to. And if we look at this reaction, the question is, what's the organic product or products? And how do you do that? You look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond to get your attention like that. I don't want to use this too much. You might get upset. So what's different? Ooh, a ketone. Carbonyl gives it away. Could have been an aldehyde. Ooh, look right here. Magnesium chloride on a carbon. That's a Grignard. Remember, X can be, in our case, it is chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon because that's where the fun is. What's attached to it, our prime and our double prime, are still attached. The carbonyl opens up to an alcohol, OH, and my R triple prime bonds to what was the carbonyl carbon. And this bond goes from the carbon that had the Grignard to the carbonyl. So here's my R double prime, R prime, R triple prime. I'll draw this carbon that was this, R prime, methyl, R double prime, methyl. OH. And now I have my R triple prime. Do you break carbon-carbon single bonds? No. I have 3 carbons. Which carbon has the magnesium halide? The center one. And that's the one that will be bonded to what was the carbonyl carbon. And in one step, we took a simple Grignard and a simple ketone. We made a very complex alcohol because you made a carbon-carbon single bond. Dr. White's very happy now. Now you know I'm an organic chemist. All right, now let me remind you, carbonyl, 1 pi bond, 1 sigma bond. And like a carbon-carbon double bond, a carbon-oxygen double bond can be broken or hydrogenated by hydrogen and a catalyst. Remember, the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each atom, in this case, carbon and oxygen, of the carbon-oxygen double bond get a hydrogen. And this is a nice way of making alcohol. The problem is, if you have a carbon-carbon double bond in the R prime or R double prime, you'll lose it too. And if you don't want to, what do? Well, you use lithium aluminum hydride, LiAlH4. And second step, H plus, and water. And Dr. H.C. Brown, and I think he was at Purdue, not University of Indiana, won the Nobel Prize in about 1970 for discovering this reaction, or inventing it. And if you take an aldehyde or ketone, you use lithium aluminum hydride, second step acid and water, you break the pi bond, and each atom of the double bond gets a hydrogen. Now, the beauty of lithium aluminum hydride, which I won't test you on, but it still tell you about it, is it will not attack carbon-carbon double bonds. And finally, the last reaction I'd like to talk about is the aldol condensation. And this is another way of making a carbon-carbon single bond. If you have an aldehyde or ketone, the carbon bonded directly to the carbonyl carbon, called the alpha carbon, has acidic protons. And if you react it with a base, you can pull that off to form an enolate anion. Now you're getting something very near and dear to my heart, because my PhD thesis dealt with a very specialized enolate anion. But anyways, and this enolate anion will attack another carbonyl, the aldehyde present, and form a carbon-carbon single bond. And this forms the aldol product. And this is how you can make also carbon-carbon single bonds. Very rare, very special. And with that, that's all the reactions for test 2. But before I let you go, I think we should have some fun. How would you like to play that fun game? Circle and name the functional group. 2 points each. Let's do it. And I'm going to be so nice, I can give you two of them to have fun with. And there you go. Circle and name the functional group, 2 points each. I'm not asking you to give the IUPAC name. I'm just asking you to circle and name the functional group. And I'll give you a little time to try it on your own, then I'll do it. Ready, set, go. And when you're done, give me a thumbs up, use the emoji, or you can turn on your mic and say, I'm done. All right, looks like everybody's done, so I better get to work. So how do you play this fun game? Circle and name the functional group or groups. You look for what's different, what's not carbon or what's not hydrogen, what's not a carbon-carbon single bond, should get your attention like that. And this test, number 2, the functional groups all have oxygen. And if we look here, we've got one here and one here. Now I'm going to draw the functional group. You just would have to name it. And here we have this. And what's that? An alcohol. What do we have here? Carbon, carbonyl, hydrogen. This is an aldehyde. Oh, that was fun. Let's do B. And we look for what's different. Here's, oops. Not oops. Sometimes it doesn't want to do my red pen. Here's one, oxygen. Here's another. And there's a third one. And those each are a functional group. And let's look at what do we have. Here we have ROH, carbon with the hydroxyl group. That's an alcohol. Here we have carbon, oxygen, carbon. Again, you don't have to draw the general functional group like I am, but if this were on a test, you'd have to write, this is an ether. Are we done? No, one more. Here I have a carbon here. Carbonyl, carbon here. And this is where R and R prime are connected in a ring. And this is, and Dr. White's real happy now, a ketone. And that's how you play that fun game, circle and name the functional group, 2 points each, 2. And this is very important, even though it's a fun game. If you can't identify a functional group in a molecule, how can you name it? You can't. If you can't identify a functional group in a molecule, how are you going to determine how it reacts? You can't. So even though it's a fun game, this is very important. So with that, I'm done. Remember, Thursday at 8 a.m. or earlier, I'll send out the password for test 2, and you'll have until Friday, 8 p.m. Now, good part of Thursday, even though I've got both days, I've got some appointments I have to go to. I'll be checking my email. If you have any questions, email me. Remember, in my class, in my world, there's no such thing as a dumb question. That goes for when you're taking a test. Also, don't forget, tomorrow, Wednesday, from 6:30 to 7:30 on Zoom, I will have my office hour. So if you need help, come on by. And with that, I'm going to say Gehen gesund, which in Yiddish means go in health. Gehen gesund. And you know what's coming up next. Bye now. Stole that from Granny and the Beverly Hillbillies. Bye now.